Okay, so I guess it's time for a Nick and Time design update, eh? So first off, I just want to say Merry Christmas and Happy Holidays to everyone. So, yeah, stuff's going down in mid-December, but I've got lots of new things coming in, lots of new stuff to share and stuff to talk about. But first off, I'll just start by going to the website. There's a couple new things, so if you haven't seen yet, we have an online store. So everything that I'm going to sell now is going to be on this store. I'm not doing pre-orders through Facebook or any stuff like that. So anything that I'm going to have up, including prototypes, are all going to be on the store. So yeah, I guess first we'll start with that. On the REM business, the V5.2 boards should be here tomorrow. So they're actually going to be here a little ahead of schedule. So I've got the printer running now, so that we can get some orders out, because I still got some orders, but you can still pre-order them, before they're ready to ship. So they're all up in here in this business. We finally have gyroscope modules back. It took almost a year, but they are ahead of schedule too. So I actually have some gyroscopes in stock for people that finally wanted that option. Cool beans there. But like I said, these boards will be here tomorrow. And I'll start assembling them and printing them out and getting all that stuff going. So that's cool. So REMs are going to be here soon. So first on the topics of just REMs in general. So now that I've got these REM 2 Pluses going on, and there's a lot, there's a lot of different options. There's 4 different options and everything, and the prices are getting really high. I know for some people that's not a big deal and they like all the features, but I feel like I'm starting to lose track of the core focus. This is a scan tool at its roots, and I kind of want a model that reflects that more. So I've been playing with the idea of making something called the REM Jr, and it's literally just a scan tool. There's not going to be any fancy, upgrades or things like that. It's going to be just a real base model, nothing ridiculous, just scanning and diagnostics. And the biggest thing with this is going to be that it's going to be it's going to be a lower price point. So it'll be more affordable. Like, I want to shoot for something under $100. I'm trying to focus on what is actually required. So let me bring up a diagram real quick. Okay, so if you've been keeping up at all, the latest REM design is getting a bit ridiculous. There's stuff all over the place, man. Like, just look at all this. There's so much for just a scan tool. Like, this circuit board is redonkulous. There's just, it's a lot. It's a lot to make sure that everything works, that everything is built properly the way that I'm happy with it and everything. And a lot of people don't need all these features. So I feel bad for people that are buying them and, not using everything that they can do or stuff. Like, it's not necessary for everyone. So that's why I want to kind of rein it back in a little bit with the REM Jr. So there's a lot less going on. Just the basics, everything that we need, and nothing else. So we've got, the main unit and a little bit here and there and the data and the buttons, but, nothing crazy, just simple, easy, and affordable. So I've been trying to balance what kind of features should stay and what kind of features should go. Anything extra, any kind of fan control or voltage reading or extra ports or extra modules or all that crap, that's all out. I've gotten feedback that people really like the auto dimming, so I will keep auto dimming. USB updating will probably be an option, because this bootloader chip down here is, I have to buy it personally and ship it to my supplier for them to build the boards, and that takes time and money. So it'd be easier if they can just, build the entire boards themselves. And if people really want the USB update option, I can put the chip on afterwards for an extra charge. It would probably still have the USB port, so I think that even without the bootloader, you can still have data through the serial. So you could get serial data to the computer for some kind of logging. And even the micro SD slot, I'm pretty sure is not gonna make it in. I may also make it an option. I don't know. I have plenty of room. I could, but for the focus of the Junior, I want this to stay as simple as possible. KISS. Keep it simple, stupid. So these are going to feature a single color screen. These aren't going to be RGB, but you will be able to pick the color. So you could get a green screen, a blue screen, or a red screen. So that is, I want to try to keep that down to basically the only option is 1, what color screen would you like, and 2, do you want USB updating or not? I could also sell a like an update module later, like something you could buy, like a dongle that could attach to it or plug in some way. So later on, if you found that there was a software update you wanted, you could do that, or just send the device back to me and I can update it, or, you know, there's different ways we can do this. But the idea here is to, you know, cut costs down as much as possible and just reel it back into something simple. So that's the REM Jr. I'm kind of excited for working on that. But, you know, it's not just about cost, it's about simplicity. I want this to be automatic. Everything it'll be smarter. So you won't have to worry about picking the engine or figuring out the transmission or setting any options. You plug it in and it gives you the data. You don't have to think about stuff. Now, the reason why I bring up all this simplicity and automation and stuff is because we got something exciting in the mail. Okay, so all the way from the Czech Republic, from a wonderful person by the name of David, sent me an ABS module. The Renix ABS module. The beautiful Bendix 9 system that everyone despises so much. But it's a computer and it's got data in it. So I was super, super excited to hack into this thing and learn all the ins and outs and bits and stuff about that. So let's go learn about that, shall we? I hooked it up to the trusty MT2500. And we learned some stuff. And as a wonderful little Christmas present from me to all of you, we now have something called the Reverse Engineering tab on the Nick and Time Design website. Yes, I'm finally releasing all of my research on all these data streams and all this stuff. So if you're a nerd, this is the place to be. So when we go into one of these guys, we'll have a short description about what it is, where you can find the data, a little snippet of the protocol itself, how all the things are put together and what they do, and the wonderful data framing, all the business, all up in here, what it all be and what it do. So inside the ABS module, we have some prom numbers that'll probably go over the program version. We have a speed sensor for each wheel. You can see the speed of every single wheel. Tell me that's not cool, alright? From a nerd perspective, if you're like off-road or something weird like that, that'd be pretty cool. I mean, I don't know how what the slowest read speed is, but again, I'm only going off what the stream is. I never got any real live data to play with, but we've got different brake solenoids. We've got all kinds of switches, like a G switch, a differential pressure switch, a boost switch, low accumulators, pumps, relays, solenoids, parking fluid levels, all kinds of cool stuff. We got a couple question mark bytes, meaning that I have no idea what they are. They aren't registered on the MT2500, but one of them actually has data, something in it, which is interesting. We've also got error code bytes as well, which is neat. So this will actually display errors. So after the framing, we also have the bit logic. So for each one, some of these are bit-based. So every byte has 8 bits in it, 0 indexed, which means it starts at 0. And yeah, so from this true or false table, we can actually see if a thing is on or off or what it is, and you can put them all together. So that's also in there. So yeah, this is professionale, all put together and whatnot. And check it, we even got the error codes, so you can see things like an ECU test fault, a modulator fault, solenoid undervoltage fault, all kinds of stuff. But the interesting thing is, if you look up the Bendix 9 system on the website, there's actually a lot of, there's more error codes that aren't displayed on the MT2500. They might still be in one of those bytes. You know, they aren't things. So yeah, something interesting to, you know, there's always mysteries with this stuff. But yeah, I really wanted to show that off because starting with this REM Jr, I would like to add support for the ABS module. I know that, like, you know, maybe a fraction of a percent of people actually have the system, but for the 1 or 2 people that might actually have it, I think this would be a really nice addition. So I want to add this to the REM Jr lineup. Because that is one of the nice things. Now that we're getting rid of all that, you know, bonus stuff, I can use all 8 pins of the adapter strictly for data. So that means there aren't going to be any 4.0 or 2.5 liter switches to mess with, or things like that. We're going to be able to take advantage of everything right through the adapter. So you plug it in, you don't have to mess with anything, it works. That is the goal. It works for cheap. As far as incorporating the ABS support into the current REMs, that is possible through software and an adapter update. So what this will mean is on our adapter right here. So far we usually just have the switch right here to switch between 4.0 and 2.5. I would have to add another switch that would switch between ECU data or ABS data. So the nice thing is, since the ABS module uses the same exact everything as the ECU, all we have to do is send pin 5 to pin 1, and then we'll get data from that instead. But that means we can't dual read. You can only have ABS or ECU. But, you know, as far as a quick fix goes, I think that's better than nothing. But later on I may decide if I want to, you know, drop one of the extra pins to add ABS support. That'll be, you know, we'll see. Again, it's such a rare option, and so many people get rid of the system anyway. I don't want to affect the core product too much. But that is the idea for the Junior and the ABS support. So, next up is really the clocks. Everyone is always wanting the clocks. Oh man, clockety clock. So the reason why these have been so delayed is just because I kind of just wanted to focus on other projects, because I've had such a bad experience with them that I want to wait until they're perfect. But that might mean waiting a very long time. So this is our current progress, basically. I need to take everything on this board and put it on that board. Because if you notice, the buttons are in a different spot. The display is in a different spot. We have the clock module stuff and all these other things in a different spot. So I can't just take this board and stick it in a clock panel. It's not going to work. So yeah, it's getting interesting. So I'm hoping maybe what I can do is possibly just take the this board, because if we cut off the buttons, right, and we cut off that, all that stuff should fit in there like that, and we'll just have to put the other things somewhere else. But there's a height difference problem there, so yeah, I don't know. It's gonna be interesting. But the reason why I kind of bring this up is, if I were to do an REM Clock Junior, then that would make simplicity a lot easier, to the point that I could actually get one out pretty quickly. So I don't know if anyone's interested in just an REM Clock Junior. Maybe that'll be where I start the prototype board on. So I'll make a prototype board on this guy, and that'll be the Junior, and we can test everything out with a different design, and just, you know, all kinds of testing, just to get some prototypes out the door, get my feet wet. And if I can still get a hold of injection molded cases, I could get that started, and maybe it'll snowball from there and I'll actually get them out. I know a lot of people want the clocks. It's just it's so much work, and I really want them to work this time. I don't want any issues, so I've been waiting until I'm absolutely sure that everything's perfect. So that's the idea on the clocks, and just REMs in general. Next up on the list, the Trinity fan controllers. I still got plenty of those. I'm working on some interesting stuff with those. So I actually found out that there are a couple interesting goofs with them. The first one, if you haven't been on my Facebook page, this is like my developer blog. So if you ever want to see any of the nerdy stuff that I talk about, or you want to hear about design updates and things like that, this is the first place that I post everything. But yeah, on here I realized I found that there was an issue with the analog circuit for the sensors. So the way that it reads it in is through like an analog voltage through the grounds, and the relay driver also runs through the same ground. And surprisingly, that actually affects the signal. It's really annoying, and I've been trying to work on this. So one of the things I wanted to do is something I would call temperature prediction, which is, depending on where you mount your temperature sender, is how quickly it will react. So right here we have, this is the cold side of the radiator, so this is right after the fans. This is our quickest reaction time. This is our thermostat housing up here, which is, you know, a lot farther away. The cold fluid has to go through the entire system before it reaches the sensor. So one of the things here is, as the temperature climbs, the fan will turn on. So this here is our fan. When it's up, it's on. When it's down, it's off. So when it turns on, the temperature will, you know, even out and start to go down. When it hits its thing, the fan turns off and everything's okay. Then the temperature rises and blah 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 blah. So if we were to go off of this sensor alone, it would take a lot longer for it to respond, because you notice, you see how quickly this is going up and down, and this guy, it's just kind of, it's jagged. We'll get to this jagged really quick, because I didn't realize about this later. But if you were to use a temperature sensor like this, I wanted to try to figure out a way to predict how quickly the reaction time would take place. And that's what this is. So right here is our purple line. This is the temperature. And the interesting thing here is this is not a time scale. This is not an amount of time. This is a temperature scale. So every time the temperature changes, it moves a click. And this right here is our rate of change. Now the weird thing that you'll notice here, so the temperature, our rate of change, the rate of change is a little strange to think about. So anything that is negative means the temperature is going down. Even though this line is going up, it is still a negative rate, so the temperature is still going down, just at a slower rate. The second it crosses right here, now the temperature is rising. Even right here, the temperature is rising, it's just slower. So that might be a little hard to think about at first. But what this does is it measures how quickly the temperature changes. So now that we have a time scale, say, oh, this is changing at 1 degree per second. And then what we do is we figure out what is our delay. So between our fan coming on and the temperature changing, how long is that? Say there's a 14-second delay. All right, the math is going to get a little confusing here, but say that our target was 200, and we are, below that by 14. 186. So if we were at 186 and we're rising at 1 degree per second, and the fan takes 14 seconds to activate, we would want to turn the fan on right at that point. So by the time the fan is, the temperature reads, it's not overshooting. It's a little complicated to explain. It's easy to show with pictures, but I don't really have the pictures right just yet. But just know that there's a delay. So the farther the temperature probe is away, the longer it takes to react. The temperature would be going up and down a lot more. So this is really about reaction time and making sure you stay in the range that you want. But anyway, to get to the weird part. So here is a thing that I noticed. When trying to predict the temperature going off the rate, you would think that this would be smooth. So the temperature is going up at a constant rate, and then it's kind of starting to level out. And then the second the fan comes on, right, the temperature spikes out of nowhere. And I couldn't figure out why there was a secondary spike when the fan comes on. You would think that it would start to go down or it would level out. Why is there this spike? And the same on the other side. When the fan turns off, notice the spike. The fan's off, so there shouldn't really be much of a spike as far as the temperature dropping like crazy. And I couldn't figure out what was going on. It was really confusing to me, because this should be very smooth. It should follow the way that the temperature kind of does. And if you're curious, this is what it looks like at a time-based scale. So this is, notice how far the dots are away from each other, because the temperature took longer to change. But yeah, this is what's kind of going on. You see that the temperature is going up and, things, but it spikes when the fan comes on. I was like, what is this? So I started to look into averaging techniques and things like that. So I got a raw dump. I average all my signals so that they're smooth. And what that means is, if you come over here, this is the raw signal. See how jagged it is, all that blue? It bounces all around. It's really annoying, and it's just, ugh. You don't want to look at that. You don't want to see the number constantly flicking back and forth, and it's not even accurate, because this is noise. This is noise. So we want to try to clean that up. So I've been using different averaging techniques, such as the regular averaging and some weighted averaging, to make the reaction time faster. So we've got different things, like if we come all up in here, we got the difference between the raw ADC, we've got the exponential and the linear and the triangle. You notice that our weighted averages, the orange and the green, react faster, even though they're still very smooth lines. And that's something cool with weighted averaging. So I'm actually going to incorporate that into newer code. So what this means is the signal will still be clean, but it will react faster. And we like faster reaction time because that means less lag. Less lag means quicker reaction time. But anyway, in order to do that, I had to, actually get some raw data to mess with, to see what the best way to average this would be. And if you look at this data, you might notice something a little weird. Remember how I mentioned that this data here, the thermostat temperature, reacts very slowly? So then here's a question. Why does the temperature spike when the fan goes on, and the temperature drops when the fan turns off? Something's not right here. Keep an eye on this while I change this number. Ready? I'm going to change this to a 3. See what you notice. Did you see that? Let's do that again. Here's 0. Here's 3. If you notice, this is the actual temperature. So, when the fan turns on, it's actually offsetting the temperature scale. And then when it turns off, it goes back to normal. So what I did is when I data log, I have all the temperatures, and I also have each fan. So each fan will either show a 0 or a 1 if it's on. So I multiplied the 0 by a number, that number being 3, and I subtracted that from the temperature. So what that means is every time the fan is on, it is subtracting 3 degrees from the temperature. And now we have a normal temperature scale. You notice it stops, and then goes down, and then it goes up and down, and there's no jaggedness, there's no jolting. You can see that it's real smooth. But normally, for some reason, it's all like messed up, and stuff is just bouncing around, and just bleh. So, this is an interesting problem with something called analog grounds, or just grounds in general. So, for the TFC, everything goes through one ground. So right over here, so here's our adapter. You notice we have one ground. That ground is what is shared with the sensors and the fans. So that means that there is a lot of current running through the ground wire, up to, at some points, up to 500 milliamps if you have all 3 fans going, all these relays and stuff. And for some reason, when you run current through the ground, that affects the resistance reading. And it's really, really weird and annoying. So if we come over to here, this sheet here, I was doing some testing. I actually made a program that will read in the temperature. It'll turn a fan on, read the temperature again. Turn 2 on, read it again, and it keeps doing that. So up here, we can see how much current each one was. I had the multimeter over here hooked up to the ground probe to see what was going on. So when the TFC has a dim screen, it takes about 50 milliamps to run, and when the screen is bright, it takes about 73 to run. Now this is each relay I tested individually, so each one took about almost 200 milliamps to activate, and as it warms up, the resistance, like, I don't know, it takes less current when they heat up, which is interesting and annoying to try to calibrate with, because that means the hotter they are, the less, power they use, which is good, I guess, but for calculations, that doesn't help. But anyway, when we look at this, we can see, how much current each one takes. So when it's off, it's only running about 50 milliamps. Then we got 200, then we got 330, then we got 440. This is what's going through the ground line, and each time that happens, the temperature is dropping by a specific amount. So here is our chart right here. Okay, I sat here for about an hour, turning a knob. So I'd increase the resistance, and then I'd turn all the fans on, and it would turn each one on in sequence and average the reading by 3 seconds. So it would take a reading, average it, then take another reading, and blah, blah, blah. And this is what we get. So channel 1 is just channel 1. We get channel 1 and 2, and then channel 1, 2, and 3. So the closer we get to no resistance, the faster it drops. So for some reason, the smaller voltages, like the way that this works, up at the top is our ADC scale. So it goes from like 0, but with diodes it stops at like 40. So 40 to 100, like 1010. This would be super high resistance, and it's also super high voltage. Down here is super low resistance and super low voltage. So the lower the voltage, the harder of a time it has getting through the ground wire. So we'll notice that when all 3 are on and it's like at low resistance, this thing drops to like, minus 100 almost. It's crazy how much it drops. So I have to figure out how to calibrate this out so that when the relay comes on, the temperature doesn't change. Real quickly, just to reel in all this nerd stuff. So the thing to understand is that the ground wire here is what everything is sharing. The temperature probe, all these relays, everything is going through this ground wire. And that is what is causing our issue. For some reason, the more load that there is, the more of a drop that we have. So you can see that this follows a very, repeating pattern. And I actually did find a way to try to calculate this with a formula. So I finally got this down to about this error here. So this is our error chart in specific units, not percentage. So based off this rough calculation, we can kind of get the errors down to plus or minus 4 ADC units, which isn't terrible, but it's still kind of a big sweep. But if you notice, it's jagged anyway, and everything is kind of weird. So I figure as long as we can average it and kind of get a decent scale to it, that it's going to be a lot better than this. 4 units, remember 4 would be up to here. Okay, so right at the tippy top, already, anything down here, this is already dropping, like here's 4. So as long as everything was up to that, it's way better than what we got now. So that's my software fix. Okay, so you can see that the ground wire is kind of our issue. There's a bit of a blockage, there's resistance, and that's causing our goofy readings, which is really annoying. So there's 2 ways that we could fix this. One is we have a dedicated analog ground. So what that means is our temperature probe over here and our other temperature inputs would have a separate ground, so it'd be called like A ground or whatever, and that would be the analog. So for instance, the test that I did here is all I did was this. So we had a temperature probe connected here on the adapter, and the ground was connected to the ground here. All I did was change the sensor's ground from here to directly on the board, so it didn't have to travel through any of that ground business that the relays were doing, and all of our issues went away. There wasn't any drops or any weird stuff like that. So method 1 is to make a dedicated analog ground. So the downfall with the analog ground is just that it requires another pin. So we'd need 9 pins if we want to keep everything we have right now. The other thing that we can do is stop using the ground for all kinds of weird things. Instead, we could make this a positive signal, a positive controller. So right now this is a ground controller. You put 12 volts in and it just provides the ground. It's easier to sync current because you don't have to you don't have to say like, oh, this is going to be 12 volts and this, that, or the other, and supply and all this. It's just send whatever you want to ground. Everything goes there. It's really easy. It's very versatile. But I am noticing that might be confusing people a little bit. So what I could do is try to source a positive controller instead. So it would send 12 volts and then you would supply the regular ground as is. That would mean that the load is now coming from 12 volt in and 12 volt out instead of ground in and ground out. So that way the ground signal is not getting saturated with all this extra current. So yeah, that might make things easier. On top of that, people just in general are a little confused about the electrical schematic and using relays and things like that, and that's okay. I do want to make this a very simple kit, something that any dude could pick up off the street and just go, oh, okay, let's use this. So maybe I could make a super adapter. So if you want to spend a little extra money, I will have the relays included in the adapter. So all you have to do is provide a 12 volt source that could control everything, and the relays will be built in. So instead, all you're doing is hooking in your fan positive and your power positive, and the relay would do the rest, all built in. So that's an idea. So if people would be interested in that, then maybe I'll start looking into that, because Amazon has some pretty good deals on waterproof relay setups. So, if that tickles your fancy, that would be easier, then that's something we could do. But yeah, that's pretty much everything on the TFC front. Once I can calibrate all this stuff and make it more accurate and, take out all the goofy stuff, then it'll be accurate and more predictive. I want to make this thing, I want this to be called smart mode, so that way, or like smart prediction. So you turn this on and it'll calibrate all your lag and make your system more more responsive. So that's the idea. So yeah, that's all the TFC stuff. So far, and I've got plenty of boards left, so if you guys are interested, let me know. Alright, so next up in the store is something exciting. Someone's little one-off prototype idea has turned into a reality. So I present to thee the TCU Buddy version 1. This right here is just a transmission scanner, nothing engine related, just purely for the AW4 transmission. Filled out nearly as much as I can. So the things with this It's obviously, you know, for the transmission, but the big thing you'll notice is the large screen. I asked a couple people about, you know, tinier screens or savings or anything like that, and they wanted the biggest screen that you could get. So here is the monster itself, a whole 2.7-inch OLED screen with some buttons and stuff. So it's got gauges, you can read the codes, it's got a tooth calculator, so you can see what speedometer gear you need with the calibration. So you got things like tire size and all that to put in there, and that'll change your tooth calibration. So that'd be cool to match your gauges to your unit. But yeah, here's the prototype itself. Very simple, very basic, not a whole lot going on. It's really more of just a proof of concept. So, you know, for people that are interested. And it also comes with a splice adapter for other setups, which I'll talk about in a second. But yeah, it can use the Renix adapter if need be. And I guess this isn't going to friggin' load, so that's cool. But yeah, it'll display codes and data and all kinds of things, and it's got an LED. Why doesn't this work? Okay, there you go. But that's the basics of it. So why would you get this over the REM? Well, for starters, if you don't have a Renix, this is compatible with OBD1. So yeah, this is the first scan tool that I've released that is officially compatible with OBD1. So we've got Renix 86 to 90, and we've also got OBD1 from 1991 to 1995.5, which is your high outputs. The 1996 OBD2, I do not think this is going to work. I'm pretty sure it's very different, so it doesn't follow the same stuff that this does. But yeah, the interesting thing with this is that it's more than just data. This has also got physical inputs, okay? So, if we look at this picture here, so we have our solenoid inputs here, right? We've got solenoid 1, solenoid 2, and the torque converter. This is all through the data stream of the transmission computer, but the problem is this is only what the computer is requesting, not what the actual line reads. So for instance, if you have some kind of manual shifter, so you've got like switches, or you've got, you know, a different, like a manual setup that ignores the transmission computer, this won't read correctly. So what I've done is I've included the manual stuff here through the adapter. So if we take a look here, we actually have all of our pins here. So we've actually got solenoid 1, solenoid 2, and solenoid 3, which can be manually spliced from the transmission wiring shown here. And on top of that, we also have the TPS sensor. If we look at this, the TPS is only shown in steps from 0 to 7, which basically shows your, I guess the best way to explain it would be your shift pressure. So the higher the step, the more likely it's going to hold a gear or downshift, and the lower, the more likely it is to upshift. You know, so it basically, it's just 0 to 7 is, you know, the scale. But if you want a 0 to 100%, then you would manually wire it in, so you could read it as such. So yeah, if you're looking for manual things, this has manual inputs, you know, as well as the TCU codes. You also notice it's got an LED, so it'll turn yellow when there's codes available, and it'll turn red when you push the brake. And you can turn that on and off in settings. So yeah, this is the first idea of just a scanner prototype for the TCU, but we can also take this a few steps further. But before I go in there, like I mentioned, this is compatible with the Renix adapters if you just want data. So if you want a simple plug-and-play solution, you can get the Renix adapter, plug it in, and good to go. This prototype is not compatible with the REM at the same time. So you can't splice them and run them together because the data line can only take 3 volts. And REMs use 5 volts for the data line. If people, if this picks up with interest and people like this, I will make this a more professional design with surface mount components. It'll be all laid out, all fancy. But for now, we just have these guys here. So I got about 10 of these that I ordered, and they're all through a hole. Heck, you could even build them yourself if you wanted as like a kit, which maybe I'll give as an option. So if you guys want to have some fun, you know, you could build your own kit. But yeah, this right here is the adapter with everything laid out, so you can manually splice everything in for power and ground and data and all the other stuff. But I want to try to work on some other things. So first off, if you notice, we don't have a plug-and-play solution for OBD1, and I want to try to fix that. Alright, so let's turn our light on for this. So this right here is our OBD1 connector for our transmission, data, and also ABS modules are into this. So you will find this underneath of your dash, right next to the center console, either on the driver's side or the passenger side. But this is what that connector looks like. So this is the guy that's in charge of that. So if I can make an adapter to fit this, then you'd have a plug-and-play solution, because I'm pretty sure we've got ground, we've got data, and we've got our 12-volt signal. So the MT2500 uses an adapter that looks like this. So that's what plugs into there, and all that good stuff. The problem is I cannot find any information on this particular plug. I don't know who makes it. I don't know the specifics on really anything about it. This is very custom, very in-house, and there's not a lot of info. The Renix guys, it uses Molex. You know, all their part numbers are available and easy to buy and easy to find, and heck, they even have, you know, digital CAD files of the connectors. This is all I got to work just off the noodle. But something I did notice, if you look at these, they're just flat blade connectors. You know, kind of like a spade. And it looks like there is a spade size that matches with that. I think it's like 1.8 or something. There's a smaller size than normal that might actually fit this. So I'm going to try and order some of those females and see if they fit on there well and could make a good adapter. The only problem is you cannot get them in PCB pin form. So for instance, when I buy these pins, you know, it's actually like a pin that comes out of the back, which you can use to solder. The spade ones, I'm only finding crimp, and I don't want to make wires. I hate crimping wires and, you know, pulling things back and doing that. It takes way too much time. I can't do it. So if this were to catch on at all, I would have to find a faster way to produce them. So my idea is maybe just making like a super oversized hole that the whole pin could slide through, and then I could solder it to the board that way. So that is the idea. I still have to order the pins, make sure they fit, see if it's even, you know, possible. But I would like to make OBD1 support a little easier for the transmission stuff. So that is the idea number 1 for just data. Now, idea 2 gets a little more interesting. So as of right now, with this adapter, you have to cut into your wiring harness and, you know, splice the wires in. So if you're not interested in, like, cutting your harness, I don't blame you. I don't like to cut factory wires either. That's a good way to cause problems if you don't do the job right. So this right here is a TCU unit right here, the transmission controller. So it's got all the pins, it's got a connector on there, and all that good stuff. This is hiding under the passenger side lower dash panel. But the interesting thing is, the adapter that they use here is standard. Well, to an extent. So, right here I want to show 2 different computers off. So I was actually sent an HO computer to diagnose and take a look, and you can see that here are the 2 connectors. The only difference are the keyways. Notice this one, the keyway is on the right, and this one, the keyway is on the left. The middle one matches up. But here is the pigtail. So this is what connects into here. It, you know, just attaches and plugs in and blah, blah, blah. Easy as pie, right? And that just uses standard pins. Well, the cool thing is I was actually able to do some research and found out that this is a Delphi connector. More specifically, this is their micro pack unsealed 0.100, and that stands for the pin spacing. It's a 0.100 pin spacing connector. But that's the connector. This is a micro pack 0.100. The only problem is it's an old connector. So first off, Delphi has been bought out. It's now a different company. I forget. It's like some other weird crap. So yeah, you're not going to find information on Delphi. And the annoying thing is when companies buy each other out, everything moves to the new website, but they do a terrible job of porting it for years. So trying to find links that used to work and now don't work are a pain in the balls. There's the same problem that happened when Atmel was bought out by Microchip or whatever, and then you couldn't find any information on all the Arduino stuff. It was a pain. But on Mouser, they actually have some of these available. Let's see, does it say? Yeah, Aptiv, APTIV, focus you fuck. Yeah, that right there is our connector. This is the only one I can find available. And it actually fits and works, kind of, sort of, fairly well. So let's take this guy out. So if you take a look, this is the exact connector just about that is used on the circuit board. You know, it's got the pins, it's got, you know, all this stuff, so you can solder it right on. It's all great, good to go. The only issue is, as you'll notice, the keyways don't match up either of these. Not the center one, not the left one. And like I said, this is the only one that I could really find. It's a 32 pin, I think, right? 32, yeah, it's a 32 pin, 2-row, and it's the only one that I can source. So unless I try to print my own, I'd have to make some kind of modifier. I'd have to cut slits into it or something to make it compatible with the other ones. So that is part one. Part two is obviously the wire end, which I also found. So here is this guy right here, which is the, you know, the black connector business. And it looks like this. It's just the it's the shell, which is this guy right here. And as you'll notice, this one also does not, you know, doesn't line up with anything else that we have, really. So, doesn't, does that go? Doesn't fit this one. Doesn't, it kind of fits this one. The HO, one of them lines up a little bit, but, yeah, and it also, I don't think it, oh, it does fit with that one a little, okay. So that one matches. So yeah, we would have to do some modifying for keyways and things like that, but we do have the two parts. So part one is that we'd have to modify the keyways to make this work. Part two, this is only available as a wire connector, like this guy. That means you have to put all the pins in there. You have to sit there and you'd have to make a harness, basically. You know, you'd have to connect wires, and on top of that, you also have these pins, okay? These pins that would have to be crimped on and pushed into place and all that, and it gets even worse. So you notice we're still missing some pieces here. If you look at this, there's a back end to this connector. One has the bitey tab on it, and the other is just like something to help you pull it out. Both of those are not available on Mouser. There are some other websites that kind of have these available, and they're not super, well, I mean, they're kind of useful, necessary, because that's what holds it on there. But yeah, this is like a three-piece design. It's obnoxious. I'd have to sit there and crimp the wires, and it would be a real big hassle. But there is some stuff out there, so, you know. The thing I'm getting at is basically I wanted to do something like this, okay? It would be an in-between board. So what would happen is you have your TCU, you plug this in, and then this is on the board, and then you take your wiring harness and plug the wiring harness into that, and now this board sits here, and you didn't have to splice anything, and it translates everything over. It's just, you know, it's an in-between board, like a through connector thing. So that would be really easy. You know, you wouldn't have to cut any wires, and that would be real, you know, just pie. So that's an idea. I don't want to splice wires, so that's really annoying. And if I were to make something like this, I don't know how the heck I would get a pin layout and something to try to custom, like that's, it's all about the effort, man, and there's so much effort required to make your own stuff. But yeah, that's the idea. Anyway, so why is this so important? If I could get something that's real easy plug and play, I could make what would be basically a manual or semi-auto shifter kit. So what that means is you take your TCU Buddy, which, by the way, I guess I'll show you one. This was the first one I ever built. Don't mind the LEDs sticking out so much. I was having problems putting it all together. But, you know, there's lots of spare stuff in here. You know, it's nice and big. Compared to an REM, it's definitely a bigger screen. But there's a jack in here that's unused. So this is the that NanoFit Molex connector. So if we wanted to put a second jack, they're all broken out so we can do custom inputs or outputs. So you could put a controller in there or something. If you had a joystick or switches that you wanted to use to help shift, or paddles, if you wanted to have some kind of paddle shifter, if you could find it for upshifting and downshifting, what we could do is have this device be our new shifter. It'll take the data from the TCU, and it'll cut in between all the solenoids. So it'll take power away. It'll remove the connection from the TCU, and instead make our buddy the power the solenoid. So this would be shifting your transmission for you with an upgraded adapter. And then you could control what gear you're in. So you could just go like, you know, upshift, downshift or something like that, or, you know, change gear. You want it to lock in a gear, you want to stay in a gear, you want to change your shift points. If you want it to automatically shift for you, but change where it is, you know, if you didn't re-gear properly or something's not reading right, and you want it to be earlier or later, or you want it to hold gears longer or something, we could do kind of custom stuff like that. So if that's more interesting, some kind of like basically transmission shift, like a shift point modifier, that's something we could do if you're interested. So if you want to see this get built more, please let me know what you might think is interesting, and I'll see what's possible. Hopefully, I haven't really tested this much yet. As long as we're in drive, we can go through all the gears just fine, not a big problem. You could throw it into first, second, and lock between first or second, and, you know, things like that. I don't know if you have to manually shift the shifter to be able to access certain gears in certain ways. On top of being able to manually shift, there's things you could do, like locking the torque converter when you're coasting. This might force your engine into more of a fuel cutoff mode, so we could have an economy mode that forces the engine to shut off the injectors. So that is an idea that I want to try to work on, is to see if we can get economy. You know, everyone's complaining about MPGs these days, so I want to see if, you know, maybe I can improve the gas mileage of these a bit by downshifting and, you know, stuff like that. So those are some ideas. The less you're on the brake, the less you're wasting fuel. So yeah, that's pretty much it on the TCU front. So yeah, these are for sale in the store now. You can go pick them up if this is interesting. This is your first chance for OBD1, guys, if you guys are looking for stuff. And real quick, before, I know everyone's going to ask, hey, can you use these screens, the REM? No, I don't really want to. They are very annoying to work with. They make a slight buzzing sound, and that drives me nuts when I'm trying to program them for hours on end. But don't be completely downhearted. I do want to make an REM 3 at some point with a bigger screen. It is an idea. I don't know if I want to do full color, or if, you know, I want to do something kind of like this that is monochrome. I do want to do some graphic display. If you've ever looked up the MT2500, this guy, this big honking scan tool, they make something called the MT2500G or MTG 2500, which stands for graphing. It's got a really cool graphic display on it, which you can, you know, put all kinds of stuff, just like this. You can do whatever the heck you want. And I would like to do that at some point. Make the REM a little bigger with a nice screen that you can fit a lot of data on. But, yeah. So anyway, yeah, you can see the codes, and you can see that tooth calculator. You can see what size tooth you need for that. You can go in here and change your tire size, your gear ratio and all that stuff. And speed adjust as well. So on top of all that, you can perfectly correct this until it's right where you need it to be. That won't change until you're driving, but you get the idea. We've also got the solenoid, so if you want TCU or manual sensing, same for TPS, TCU or manual sensing, and the LED mode. So you got dual mode, you got brake, you got malfunction indicator lamp, or off. But yeah, that's basically everything that in a nutshell. But the reason why I don't like the screen is because it kind of does this weird thing where it like flickers and things, and that might be weird in a bouncy Jeep. And again, it makes a slight buzzing noise, and I really don't like listening to that for hours on end. So I want to find a nicer screen. If I can find a better screen, yeah, I will eventually work on that. And if we go way back, that's why the REM Jr is kind of exciting. I want to make a base scan tool, and then a crazy scan tool. And the crazy scan tool would get a bigger screen at some point. So yeah, that's kind of where I'm at thinking-wise. Actually, there's a few more little things I want to talk about. So first off is the name. I don't know if I like TCU Buddy. It's kind of long and not super descriptive. I kind of want it to be more, you know, something that gives away. It's more descriptive. So something like that would involve the AW4 transmission or scanner or something like that. And it also kind of doesn't fit the current naming. You know, most of my products have like a 3 acronym name, like the REM or the TFC or something like that. So I was thinking maybe like an ATR or an ATS for like the A's and Warner, or like the AW4 transmission reader, transmission scanner, or something like that. But I don't know. If you got an interesting name that you think might be more fitting or more something like that, I don't know. I'm still playing with the name. Depends what I wanted to do. On top of that, there's other things we can do with this. This is Arduino, and we can do really cool fancy things. So if you wanted to know transmission temperature, I could put in some kind of temperature input. So if you want to wire a sensor to this so you can have your transmission temperature displayed on screen, we could do that. We could have some kind of add-on kit to add a sensor and a plug so you can see your temperature in real time and monitor that. And even have the red light flash if it's too hot or something. So that's number one, is you could keep an eye on temperature, you know, to really deck this out as a really cool scan tool. The other thing, which might sound a little weird, is to put a flow meter into the ATF cooler. So there's actually a company called Sonax, and they make something called the SonaFlow. And here's a chart that I found for the AW4 transmission. So what this does, it puts just a simple flow meter in the transmission cooler line. You could just splice it in real easy, and it tells you how quickly the fluid is flowing. And with that information, you can kind of guess what it is mechanically doing. So you can see that the flow rate goes up when it's like accelerating and doing things, and when the torque converter goes on, it like drops and things like that. So you could do some kind of like real life like graphing thing. So if you think that that might be something interesting to look at the flow rate of the transmission, then that could also be like an extra kit thing that we could add on there. So you could see things like flow rate and temperature and things like that to keep an eye on the fluid, stuff. So if that's something interesting, let me know. Again, this is kind of like for you guys at this point. So if there's some cool stuff that you think would be neat, maybe I'll develop it more. That's the fun of this stuff, You guys kind of get to be the boss. If you want to see some cool stuff, let me know, because I like making cool stuff. So yeah, that's some stuff. Okay, so now on to the biggest and more interesting news. So I've always been talking about the OBD1 for a while now, the HO guys, and doing this and doing that, and just, basically, it's just been excuses, really. It's not been anything great. And the reason why is because it's difficult. Well, number one, it's difficult. And two, it's different from what I'm doing now. I'm really passionate about Renix. I love all the stuff about Renix, the hidden, meanings, and like all the mystery bites and all the weird things and how it works and everything in here. Like, I love that. And part of the reason why I love it is because I own a Renix Jeep. All the things I'm doing, as selfish as it may sound, this is benefiting me. I get to learn more about my system, how it works, how to fix it, how, just everything about it. And it's a fun mystery. And that's what's been keeping me going. The Renix guys we're such a tight-knit group of people to try to keep some old history alive, and it's fun. And I don't get that spark with OBD1. And that's a big problem. I need that spark to keep going, otherwise I lose motivation, and it's hard to push through this. This takes years of work, so you need to have the passion behind it. It's not all about the money for me. You'd be surprised if you saw my profit margin. It's not that great. This is really just to get stuff out there for fun. So, while doing some searching, if you look up the Chrysler CCD or SCI bus, the Chrysler Collision Detection Bus, and the Serial Communication Interface, that's what OBD1 uses. So first off, they got two interfaces for the same stuff, and that doubles the complexity for which one do you want to look at. But I found this site here, this Chrysler CCD SCI WordPress site, of some dude basically doing what I'm doing, but for you guys. He's actually working on circuit boards and 3D printing cases for his own little scanner. I noticed in one of the pictures he's got like a screen over here that actually says some stuff, if you can read that. Oh, it's so bright. But yeah, he's basically doing the stuff that I'm doing. He's taking a slightly different route, but he's got like software that like goes on like a Windows computer to read everything in, and I think that's really, really cool. So he's doing the stuff that I've been meaning to do, but just don't have the time or passion to do. But you're gonna see shortly why I've been so unsure about this. So he's actually using an ATmega as well, and his stuff is open source like mine. He's sharing his information and all that, and I really like the way that he's going. So I really want to show this out. Bring this to light to show his information off. But as you can see, his stuff is difficult. Like, it's different from mine. You have to send messages, all right? And each message is a bunch of things in this frame. You have to go, okay, here's the thing. I want to read something. I want to get data, and it'll send you data back, and you have to wait, and it's slow, and it's confusing, and there's like, oh my lord, there's so much going on. Like if you look up here, he's actually got a command history of like descriptions, so it'll connect. There's a handshake, there's a scanner found, there's a status packet and things, and you have to talk to the computer. Everything I've been doing so far is just reading. I know how to read, but I don't know how to write. And this is, it's completely difficult, confusing thing when you look at this stuff and you go, okay, there's a frame, each thing means something, we've got a checksum, we've got parameters, a command, a target, so you have to target what you want to talk to, you have to tell it what you want to do, you have to ask a thing, it'll respond with the thing, and on top of that, the hardware to actually interface with this is also kind of confusing and annoying. So it's not even as easy as this stuff. It's like, it's years more complicated than what I already know how to do. So that's why I haven't gotten into this. So to see this guy doing the same stuff that I'm doing, like, look, like, I've even taken pictures like that with the PCBs and everything and how everything's all open. Like, I love what this guy's doing, and I want to give him some credit and some publicity. And like I said, he's got his own reverse engineering tab, which kind of, made me want to post my own. Because he's gone through and, look at all the stuff that he's going through to try to figure this stuff out, man. He's, like, looking through the ROMs and trying to, like, figure out computer language. Like, this is, like, super low level. I forget what this is called. Like, it's like, the binary code. Like, this is what's on the computer. This isn't even the code people write. This is the code the computer reads. And you gotta sit there and figure out where it all goes and what all this stuff means and break it apart, and it's a lot of work, man. Like, seriously, this guy's got some brains on him. So I'm really trying to, send this home that what he's doing is amazing. And I really hope that his stuff catches on. He's sharing his stuff. And I don't know, I might talk to him and see what he's trying to do. If he wants help with trying to, turn it into more of a business, or to try to help him out or anything like that, or if he wants to go his own route, or, we'll talk and see. I have messaged him a couple times, and he's interested in the stuff I'm doing too. So it's cool, but, I just, I want to say that the stuff that this guy's doing is incredible. So, yeah. Keep it up. You OBD1 guys, you're not totally left in the dirt. Someone else might be your hero. And honestly, this will help me out, because I won't feel so guilty. Because I want to delve so deep into the Renix. I want to become it. I want to go as deep as I possibly can and figure out everything. And trying to switch gears to a different computer system is not conductive to that. I'm not going to learn everything I possibly could. I want to be the Renix master. I want to be the very best. And you feel me? You understand? You know what I mean? So yeah. I might not be able to guide to be your bread and butter for OBD1, but hopefully this guy can. So we'll keep an eye on that and see where that goes. But anyway, that's all for now. This video is probably long as hell and obnoxious, but yeah, we've got circuit boards, we've got stuff, we're working on things, we've got things planned for the future. So, yeah, I think that's just about it. So, yeah, Merry Christmas, Happy Holidays, and a wonderful New Year. And if that offends you, go fuck your hat. So obviously you're too offended to accept a greeting.